So here we have our second exercise in nonlinear system. Solve the system y equals x squared minus 5x plus 1 and x minus y equals 4. I just want to say right up front that we're going to go through this once, and then after we get our solution, I just want to talk a little bit about alternate methods that could be applied. I think it's important to realize that there's almost never one single path that has to be followed. There are almost always many acceptable ways to work through the steps, and certainly recognizing certain shortcuts can be really helpful to keep things from getting too messy. But first, let's just go ahead and start this, get through it one time. And you don't have to recognize the shapes to do the algebra, but I think here again these are equations we're very familiar with. Y equals x squared minus 5x plus 1 is the equation of a quadratic function. Its graph is a parabola. X minus y equals 4 is a line. So we're looking at a parabola and a line intersecting each other. And we're, let's call these equations 1 and 2. And let's go ahead and get started here. Now, in this problem, I already have y isolated in equation 1. So if we already have a variable isolated like this, y equals x squared minus 5x plus 1, we can move right to the substitution step. So let me just note that down. I already have y isolated in equation 1. So let's go right ahead and substitute into equation 2. So let me copy equation 2 down here, x minus y equals 4. So what I'm doing is I'm going to replace the y with this quadratic expression in x. So instead of x minus y, I'm going to write x minus x squared minus 5x plus 1 equals 4. And probably the trickiest thing of all here is that if you're going to substitute this expression for y behind a minus sign, I need parentheses, and I need to distribute the minus sign. This is like one of the most common errors I see, where a quantity has a minus sign in front of it and people forget to distribute the minus sign. So when I distribute that minus sign, I end up with x minus x squared plus 5x minus 1 equals 4. And now I have an equation in just one variable x. I had it back there too, that we could solve for x. And it's quadratic in x, and this x squared is negative. I want a positive x squared coefficient, and there's what I'm going to do is I'm going to take all the terms to the left-hand side of this equation. Actually, let's see. Before I do that, let's just get this disorganized on the left here. I want to write minus x squared. I want to add the x plus 5x is plus 6x minus 1 equals 4. And now I'm going to go ahead and take those terms to the right-hand side. So I'll have a 0 here on the left. You could equivalently multiply both sides by negative 1 if that makes more sense to you. That will accomplish the same thing. So if I add x squared to both sides, I get a positive x squared, subtract 6x from both sides, add 1 to both sides, and I have my 4. So I end up with 0 equals x squared minus 6x plus 5. And that's a quadratic equation, and I want to solve it in whatever way I can. the quadratic formula is always a possibility, but if I can factor, that will be nice. Let's see if we can factor this, x and an x. If it factors, both signs must be minus, because we have a minus in the middle, plus on the end. And the only way to factor 5 is 5 and 1. And I think I have negative 5x plus negative 1x is negative 6x. That's actually going to work here. So x minus 5 equals 0, or x minus 1 equals 0. X is equal to 5, or x is equal to 1. And again, I have to find the corresponding y values. And so I'm going to take my x, and I can plug into any equation where x and y occurs in this problem. It's a little bit less complicated to use my x minus y equals 4. I'm going to plug in 5 for x, minus y equals 4. So I can see that y is 5 minus 4, or 1 is y. So I have the solution 5, 1. And for x equals 1, if I plug in 2x minus y equals 4, 1 minus y equals 4. So y is equal to 1 minus 4. And so negative 3 is y. And so I have 1, negative 3 is my second solution. So once again, here's a problem where there are two solutions. Five, 1, and 1, negative 3. So there's our answer to the problem. But now we're done with the math, but we're going to talk about this a little bit more. I want to do a couple things. One is I want to look at a graph and just think about what this means graphically. And my solutions are there. I guess I'm going to push that off the edge a little bit. And what I did, I prepared this ahead of time to save us some time in the video. We're going to graph both these equations. I have a parabola and a linear equation. I plotted some points, or I computed some points ahead of time for the parabola. I also found the vertex. We know how to find the vertex for a quadratic function. Its x-coordinate is 2.5. That's that negative b over 2a formula that we use. And I plugged in and figured out what the corresponding y value was, so got some decimal values there. So for the parabola, we have 0, 1, so y-intercept, 1, negative 3, and 2, negative 5, and then 2.5, negative 5.25. So halfway between 2 and 3, just down a little bit, slightly below there is the vertex. Then I have 3, negative 5 again, 4, 3, 5, 1, and I think that's enough points here for me to be able to draw this quadratic. I did not find the x-intercepts. I don't need them here. So there's the quadratic function. The line, again, I can write it as x minus 4 equals y, or y equals x minus 4. So that's a line with y-intercept negative 4. And it's got slope 1 again, just like our previous example. So I've got another easy one to graph, because if it's slope 1, I can just go up 1 over 1, up 1 over 1 to get more points. More points, more points, more points. Here's my line from the second equation, second example. And I can see the points of intersection are 5, 1. And right here is 1, comma, negative 3. And I hope that's what we got when we did the algebra. Let's just go back and look when we went through the algebra, the thing, we got 5, 1, 1, negative 3 for that system. And there's trying to get the whole thing on the screen. So there, we're done again. But just before we quit completely on this one, I just want to go back and say a couple things about alternate approaches. There's probably something at least I would have done to try to make this a little bit less messy to go through. So let's just maybe call this alternate method 1. I'm not going to go through all the steps. We're just going to get started. So what if we again label these equations 1 and 2? I probably would have, I'm going to say rewrite equation 1. Take that x minus y equals 4. I might have started out by just adding y to both sides of that. X equals 4 plus y. Then I have a positive coefficient on the y. And then I could substitute, sorry, I rewrote equation 2, I meant to say, is the equation I rewrote. Rewrote equation 2. And then I'm going to substitute from equation 1. So I'm going to take my x equals 4 plus y, my rewritten form, and into that I substitute the expression for y from equation 1. X equals 4 plus x squared minus 5x plus 1. The nice thing about this is I have no minus sign to distribute, right? It's a little easier to manage. And I'm just going to say etc. We're not going to go through all those steps. I want to give one more alternate method. Alternate method 2, and I'm sure there are more than 2. What you might have done to start out this problem again is you might have chosen to isolate x in equation 2. So take that x minus y equals 4. Think of that as isolating x equals y plus 4, similar step to what we just did. And substitute into equation 1. So this is very different from alternate method 1. So we're going to take our y equals x squared minus 5x plus 1. And here the substitution that I'm going to make is the 4 plus y for x. And that's going to occur in two different positions. Y equals 4 plus y in parentheses squared minus 5 times 4 plus y plus 1. And here I get an equation in y. It doesn't matter whether it's an x or y. We just need an equation in one variable that we can solve. So again, I'm just going to say etc. because the solutions will come out the same in either case. But it's just, I think it's just interesting to talk a little bit about how there's more than one possibility here. And just one last time, I'm going to flash the whole problem that we did the first way. And so no matter which method you use, you should get 5, 1, 1, negative 3, which are the 2 points of intersection of the parabola with the straight line.